Hi, I want to talk about this example in which we have the transformation y equals x squared and the density function is 3x squared for x between 0 and 1. We want to determine the density function of y and the range of values for which the density function applies. This example has the same density function as another example. However, the only thing that's changed is the transformation y equals x squared. After all, how much could things change just by changing one little detail? Well, let's get started and find out. I'm going to start with finding the density function and recall that the derivative of the cumulative distribution function is the density. Okay, well, the cumulative distribution is the probability the random variable y is less than the given value of y. And I can replace y with x squared, the transformation. Okay. Now I'm going to solve for x. After all, I know how to calculate probability with x. So you're probably going to take the square root, but remember there's positive and negative values of y. Okay, so now I've solved for x. I said I know how to calculate probabilities with x. This is the integral from minus root y to positive root y of f of x dx. After all, I have a probability stated in terms of x. Okay, but I look at this formula for f of x, it only applies when x is greater than 0. So that bottom part shouldn't be negative y here. It's 0 because the density function only applies for positive values. So this will be root 0 to root y of 3x squared dx. It's noteworthy to say that if our density function was not 0 for negative values, then we keep that negative root y. And that's a very subtle detail, but an important one. But here, since our density function only applies for positive values, we don't keep it. So keep that in mind. Okay. Now I know how to anti-differentiate this. This is x cubed evaluated from 0 to root y. And this will be y to the 1/2, that's square root of y, quantity cubed minus 0. So y to the 3/2. That is my cumulative. So this is g of y, which is the CDF. I want the density. So the density, that is the derivative of this. So d over dy of y to the 3/2 power, this will be 3/2 times y to the 1/2. And this is the density. Okay, when does this apply? I mean, after all, it's not sufficient to give me a density and then to calculate probabilities. I need to know for what values of y. That was crucial here. It said our density was 3x squared for x between 0 and 1. And we used that interval to calculate this density. But we can't do anything without knowing the values of y. We can't calculate probability, we can't do expected values, etc. So when does the density function apply, or when is it non-zero? Well, let's graph this transformation. Transformation is y is equal to x squared, right? And x is between 0 and 1. So that's important to keep in mind. 0 and 1. So where are those values on the x-axis? Well, it looks like it's 0, 0, 1, 1. So the y values are between there and there. So if someone asks where does it apply, 0 less than or equal to y less than or equal to 1. And let's just check. Technically, I don't need the less than or equal to, but it doesn't technically matter because probability of a point is 0. So if you were asked where does it apply, you'd give this response. Okay. Thank you very much.